Welcome to Algebra 1 Honors. Today we are going to cover 3 lessons combined into one. Your book breaks factoring, which is very important, by the way, and you'll see factoring on your standardized tests when you go to take your test for college. So make sure you remember how to factor, because factoring, again, is very important. But your book breaks it up into 3 or 4 different lessons. And we're going to teach you one method of factoring, which your book calls special factoring, but which works for everything. So that way you don't have to clutter up your brain memorizing 5 or 6 different ways to do things. You can learn one way and it works for all of the different cases. So this is lessons 5-7, 5-8, and 5-9, all combined. Okay, we're going to show you one method for factoring that works in anything that is factorable. Okay? Now, let's start with this problem right here. We have a trinomial. It has a square term, a linear term, because this variable has a 1, a linear exponent, which we don't write on it, and then a constant term. Now, here's how we're going to factor. There's actually a 1 here in front of the x squared that we don't write if it's a 1. Okay? We're going to find 2 special numbers, and we're going to find them by looking for 2 numbers that when we multiply them together, we get this number times this number, including the signs. So positive 1 times positive 26. We want 2 numbers that when we multiply them together, we get positive 26. And those same 2 numbers, okay, when we add them together, when we add those same 2 numbers together, we want to get the coefficient here, negative 15, okay, right here. All right, so we might start with 1 and 26. All right, if we have positive 1 times positive 26, well, that'll give us positive 26 when we multiply them together, but when I add positive 1 plus positive 26, I don't get negative 15, okay? So I look again and I think, well, okay, if when I multiply them I get a positive, but when I add them I get a negative, both of my numbers have to be negative, okay? So let's try negative 2 and negative 13. Let's see, negative 2 times negative 13 gives me a positive 26. That works. And over here, negative 2 plus negative 13 gives me a negative 15, and that's what I want. So negative 2 and negative 13 are the 2 numbers I'm looking for. Okay? I'm going to take those 2 numbers, write them down, and I'm going to put them on a pedestal because I'm really proud of those 2 numbers. And the number that's going to hold up my pedestal is the number in front of the square term. In this case, it's 1. Okay? Then I'm going to look at those 2 fractions and I'm going to see, can I reduce either one of them? No, I can't reduce them. Okay? So I'm going to imagine that my pedestal is there and they're rooted to the ground. Okay, they're on the ground. And I'm going to push the top number. I get over here and I'm going to push the top number off. So it's going to tumble, and the 1 is going to stay in place, and the negative 2 is going to tumble over here. And then I'm going to come over here and do the same thing. I'm going to push that top number off. So the 1 stays in place, and the negative 13 tumbles over to the right. Now, I'm almost done with factoring. All I have to do is put my parentheses in and put my variable name, which happens to be an x in this case. Okay? And my factor, the 2 binomials, that when I multiply them together will give me this. I can write the 1, but usually we leave the 1 out if it's 1x, and I'd write x minus 2 times x minus 13. Now, let's double check and make sure we did that right. I should, when I FOIL, I should get this back again. So let's see. First, x times x gives me the x squared. The outer, let's see, that's the guy's chin there. X times minus 13 gives me minus 13x. Inner, that's the guy's mouth there, gives me minus 2x. And last, we've got to close the guy's head up there. Minus 3 times minus 13, or minus 2 times minus 13 gives me positive 26. And these two are like terms, and when I combine them, I get minus 15x. X squared minus 15x plus 26. Okay, so my check is to FOIL my binomials and make sure I get the original trinomial back again. All right, now let's try this one over here. Using the same procedures. So I'm looking for two special numbers. When I multiply those two special numbers together, one here, I want to get 1 times positive 12 or positive 12. And when I add those two numbers together, I want to get a positive 7. Okay? Well, I might start off and say, how about 2 and 6? If I have positive 2 times positive 6, I get positive 12. Positive 2 plus positive 6, I get positive 8. So those aren't my two numbers. Then I might try 3 and 4. Positive 3 and positive 4. When I multiply the two, I get positive 12. And when I add them, positive 3 plus positive 4, I get my positive 7. So those are my two numbers, plus 3 and plus 4. So plus 3 and plus 4, and I'm proud of those numbers. So I put them on a pedestal. What holds up my pedestal is the number in front of my x squared, or my squared term, which is 1. I look to see, can I reduce either one of those? In this case, no. So I imagine that my pedestal is rooted to the ground there. Okay? I'm going to stand over here on this side and I'm going to push that top number off. So I'm going to have 1, and that plus 3 is going to land over there. I'm going to do the same thing up here. I'm going to have 1, and that plus 4 is going to end up over there. And then I'm done, except for putting in my parentheses and my x's. Okay? Now, let's try one that's just a little more complicated. What if I had one with two variables? Okay, I'm still looking for two special numbers. When I multiply them together, I want to get 1 times positive 48, or positive 48 there. And when I add them together, I want to get negative 16. Right? Well, I might try, let's see, 3 and 16. And since this is a negative, one of my numbers has to be negative. So how about negative 16 times positive 3? Well, that won't give me this positive here. So let's try negative times negative. Negative 16 times negative 3, that gives me positive 48. But when I add negative 16 2 negative 3, I get negative 19. That's not what I want. Okay, let's try 4 and 12. Negative 4 times negative 12. That gives me positive 48. And negative 4 plus negative 12 gives me negative 16. So those are my two numbers. So I take my special numbers and I put them on a pedestal because I'm proud of those numbers. And that 1 over there, that number in front of our square term, holds up my pedestal. I check to see if I can reduce them, and in this case I can't. I imagine they're rooted to the ground here. I push them over, and I get 1. Minus 4 goes over here. I push this guy over. I get 1, and minus 12 comes over here. I put in my parentheses, put my x's there, and I'm done. Okay? Now, let me flip the board over, and we're going to try 2 that your book calls special factoring. That's what we've been showing you. And so as long as you follow these steps, this method of factoring will work for anything that is factorable. Okay? All right, let's try one. That's a little bit harder here. Whoop. Up and on this one. Okay, I still want my two numbers. I want my multiply number to be 2, my number here, times positive 7 or positive 14. And I want my add number to be this one right here, negative 15. Okay? Now, if I look at that, I say, okay, what if I had 1 times 14? Well, that will give me my positive 14, but not my negative 15 over here. What if I made them both negative? Negative 1 times negative 14 gives me a positive 14, and when I add them together, I get a negative 15. So those are my two numbers, my special numbers. Negative 1 and negative 14. And I'm very proud of them, so I put them on a pedestal. Now, the number in front of the square term holds up the pedestal. I put a 2 here. I put a 2 here. Now, can I reduce either one of those? In this case, yes. I can reduce, divide by 2 here, I get minus 7. Divide by 2 here, I get 1. So now I have minus 1/2 and minus 7 over 1 after I reduce. Okay? Now, I imagine they're rooted to the ground here. I push them over and I get 2 minus 1. Push this guy over and I get 1 minus 7. Go back and check. Let's see, my variable's an x, so I put an x here and an x here, and I'm done. Now, let's do the last one, because I think I did the one with 2 variables on the other side incorrectly. We should have put another variable in there when we got done. So we'll do this one correctly, and you can go back and look at that one. Okay, was the right answer, it just didn't have the second variable in it. Okay, here, same thing. We're going to look for 2 numbers that when you multiply them together, you get 4 times negative 9, or negative 36. And when you add them together, you get positive 16. Okay. Well, you might try, let's see, 4 and 9. Negative 9 times positive 4. That's going to give me negative 36. Negative 9 plus positive 4, though, is going to give me negative 5. So that one doesn't work. what if we try 2 and 18? Negative 2 times positive 18. That gives me negative 36. And negative 2 plus positive 18, that gives me my positive 16 there. So, negative 2 and positive 18 are my special numbers. Okay, now I'm going to put them on a pedestal. Pedestal is held up by my coefficient of my square term, 4. Now, can I reduce? In this case, I can reduce both of those. And I end up with minus 1/2. And over here, positive 9 over 2. Now, they're both reduced. We're going to anchor them to the ground and push them over. So we get 2 minus 1 and 2 plus 9. Put my parentheses in. Okay, and now I have an x here and a y there, so I need to put an x here and a y there. An x here and a y there. Okay, I think on the previous one, and we're done. That's the answer to that one. Let's double check. Yeah, here we go. This one, we should have had a C here and a D there, and a C here and a D there. So we got the right numbers, but just forgot to put the variables in correctly. Okay? So that's obviously something to be careful about. Okay? But that's what special factoring is all about. And that kind of factoring will work for anything. It'll even work for the difference of two perfect squares. Let's do one of those real quick. What if you had 4x squared minus 100, and you wanted to factor that? Well, the first step, the things we always forget, is to take out any common monomial term here. So we can take a 4 out of both of these. 4 times x squared minus 25. Now, then we're going to factor just this right here. Well, it's not a trinomial. Okay? Well, we can make it a trinomial, though. It's only a binomial. It only has 2 terms. But we can make it a trinomial by saying x squared plus 0x, because that's what's missing, minus 25. Okay? Now, then I factor it just using my regular factoring method. 1 times negative 25, that's my multiply number. So my multiply number is a negative 25. My add number is a 0. And 0 is not really positive or negative, it's neutral. Okay, so when I add, I want to get 0. And that's pretty easy to see. 2 numbers that I multiply together to give me negative 25, but when I add them together, I get 0. So the numbers have to be opposites. One is plus 5, and one is minus 5. Okay? So I take a positive 5 and a negative 5. Those are my special numbers. I put them over my pedestal of 1 here. I root them to the ground because they can't be reduced. I push them over. And I get 1 plus 5 here, 1 minus 5 here. And let's see, we're dealing with x, put the x in. Okay? And so my final result, I can't forget the 4 that I originally factored out back here. Put that right there, and we're done. And so this method works for anything which is factorable. Now, let's look at one thing over here real quick. What if you had and you want to factor? Well, you come over here and you make your little table. So my multiply number has to be 1 times positive 3 or positive 3. And my add number is going to be, my add number is a positive 7. Now, the factors of 3, we have positive 1 times positive 3. All right, that gives me a positive 3. Or positive 3 times positive 1. There aren't any other numbers. And when I add those two numbers together, plus 1 and plus 3, or I could have minus 1 times minus 3, minus 1 plus minus 3. But neither of those work. I get a positive 4 here and a negative 4 here, not a 7. Okay, so this particular trinomial, when you've tried all possible combinations and you cannot find anything that works, this is called prime. Okay? Prime means that it's not factorable. You can't find two binomials that it factors into. And you will have one or two of those in your exercises. Okay? But that's factoring. So the special factoring method works for any kind of trinomial which is factorable.